Good morning, everyone. So in this video lecture, we're going to talk about CMYK model. Actually, I intended to create a video on CMYK model long back, but I couldn't find time. So yesterday only I received this query. What is CMYK model? Why do we use it? How is it different from CMY? Like what was the need to have K with CMY? And how it is different from RGB, right? So we will discuss all of that today. And there are a lot of color models, okay? And they all serve a different purpose. And the reason we have this, there are two main models that we use or discuss. These are RGB and CMYK model, okay? So I have already created a video lecture on RGB model. I will post link to that video in the description, okay? I will share the link to that the video RGB model in the description. And if you have watched that video already, you will know that we discussed in that video lecture, we talked about the concept of RGB model and that it is used for digital work. Okay, so digital work meaning everything related to screen. Okay, whatever you are, when you look at the screen, there are different colors, right? So this is all RGB work. And if I need to give you a very simple example, it would be the monitors, computer monitor, where I'm sure you have heard of the concept of CRT, cathode ray tube, where RGB gun concept is very famous. RGB, red, green, blue, right? So RGB model is used for digital work, right? And it is additive model. We have already discussed additive and subtractive model as well. I will also share the link to these in the description, right? So CMYK, RGB is about digital and CMYK is the opposite, right? RGB is additive model, CMYK is, and at the end of the video, I will also give you difference between these two if you ever need, so CMYK is the opposite and RGB is additive and CMYK is subtractive model, and it is used for printed material. Okay, CMYK is used for printed material. So basically physical copies, not on screen work, physical copy, something that you can touch. Okay, so it all starts with CMY model, right? So we had CMY model in the beginning, and if you remember RGB color space, white color was at 111 and black was at 000, meaning when no color is mixed or added, black is formed, and when all the colors were added, white is formed, right? White gets created. In CMYK or CMY model, it's the opposite. Okay, so 111 is black. So basically when all the colors are added, now in CMYK model, and I will explain it, this thing also, we are talking about subtraction, right? So in CMY, first of all, we make use of pigments, okay? So it is like colors will be added. When you add them, they are actually subtracted or they are absorbed, okay? So and I'll explain the whole concept. For now, just remember that in CMYK model, when all the colors are added, black is formed. So 111 would be black and 000 would be white. Okay. Now, let me first give you an idea of subtractive model and how it works. So in subtractive model, ink or pigments are used. Okay, you can also call it dye, DYE, dye. right? And I'm going to address it as colorants, right? Or colorant, right? So it can be dry color, it can be liquid color, etc. And an example, for example, for RGB, I gave you the example of monitors CRT, cathode ray tube, and for CMY model, I can give you the example of paint on the wall. Okay, it is based on subtractive model. It is something you can touch, right? So basically, this colorant is used to generate color using the principle of reflected light. Just like primary colors of light are red, green, and blue, primary colors or components of a colorant. So do you see the difference? In RGB, we are talking about light, but in CMY model, we are talking about colorants. So we have something that we can touch. We can actually, something physical, right? So primary components, when we talk about RGB, so primary components of light were red, green, and blue colors. And when we talk about CMY model, where we are dealing with physical things, we are dealing with printed material, primary components of a colorant would be cyan, magenta, and yellow, CMY. Okay, and why do we have K? I'll let you know. Now, what is this principle of reflected light? I told you that this colorant is used to generate color using principle of reflected light. What is this principle? I'm sure you all know that in RGB, when light is let to pass through a prism, right, a prism, it separates light into different colors, right, just like rainbow. And in this image, actually, I just drew it like it's not a work of, I did not put that much effort. So just consider it like, light, and these are different colors of different, these are frequencies, of different colors. And since I really wanted to finish this video today, I did not, I just didn't feel like I have to, show every single color, because we have already talked about it in previous video lectures. So I'm sure you can get the idea, and I am sure you know how this whole thing works, right? So when light passes through a prism, different colors can be seen, right? The light separates into colors, different colors, right? Just like rainbow. But so suppose this is a wall, okay? A wall doesn't do that, right? Your clothes, they don't do that. Color is not like, it is not, there is no separation of colors or a rainbow or something like that is formed. Why? Because these physical objects contain chemicals called colorants or pigments, okay? And these colorants will absorb certain light frequencies and they will reflect others, okay? And reflected frequency or color reaches your eyes. So this colorant actually prevents certain colors from reaching human eye, right? That's why it is called subtraction. So if many colorants are combined, so colorants will have, pigments, dyes. I'm sure there are different colors of dyes and even inks. Right? We have blue ink, red, green, and all of that. So if many colorants are combined, that many colors are subtracted and they won't reach the eye. For example, if you have orange colorant, red colorant, and let's say indigo colorant, and you mix them all, these three colors will not reach the eye. So they are sort of subtracted, they are absorbed, right? So that's why this is called subtractive color model. Okay, so this is the whole funda, or this is the whole concept behind this CMY model. Now CMY in CMY, when all colors are subtracted or, metaphorically added or absorbed, black is reflected. When all the colors are subtracted or absorbed, 1 is for black, so black is reflected. And when no color is subtracted or no color is absorbed, all the colors are reflected back, white is formed. And this is very basic concept actually. I'm sure you've learned this concept in I'm not sure in which standard, but it definitely was a part of science class. So yeah, that's what it is. That's what CMI works on. CMI works on this principle that when all CMI colors are mixed, now mixing causes the absorption. Try to understand that. Absorption is when you mix it, they are absorbed, right? So they are absorbed, and that's why they are not reflected back. When you mix all 3 colors or 4 colors, how many colors you are mixing, they are absorbed, and so they are not reflected back. Okay, so black is formed, right? So that's the concept of CMY. But when printed actually started, it was noticed that in reality, the color that came after mixing all the colors, basically these 3 components, C, M, and Y, cyan, magenta, and yellow, the color that actually came out was brown and not black. Okay, so there was this need to use black separately, so that is why K was added. So CMYK, K is for black color. Okay, and that is why concept is the same, but CMY and CMYK, so K we have a black color, right? It can be formed in CMY model as well, but it was observed that the end color is not very close to black. It is actually brown, or at least close to brown. So sometimes there is need to use black color, and that's why CMY and then K, black was then separately added. And if you have used color printers, you would know that you have those, CMYK models, right? So yeah, that's what it is, and I hope it made sense. I hope it answered your question. If it didn't, feel free to ask. Maybe modify your question a little. If your question is clear, I'm able to answer it with more explanation and clarity, and I'm able to touch the points that you really want to be touched. So that is it. And this is the difference between additive and subtractive model. If you want to note it down, you can. And here I have also used additive model is associated with bright colors, and subtractive model is associated with dark or muted colors. And I remember long back somebody asked me the difference between both. So as per my understanding, bright colors are in pure form and muted colors are mixed. And I can give you a very simple example. On a sunny day, when you see the color of the sky, it is very bright. You will not see any mixture or anything, right? It will be very bright. And in fact, the color of this statement, on a sunny day, sky color is bright. The color of this statement in itself is bright. Okay, so this is bright color. And if it rains heavily, or if you see cloudy sky, if there is cloudy, it is very cloudy, colors are very they are dark and mixed, and they are all kind of like oranges mixed in blue and all of that. So those are muted colors. Okay, and if I have to say pure form of green and dark or muted form of green, this is the difference, right? So on a sunny day, sky color is bright. This is, for me, this is pure form of green. So this is bright color, and colors in the sky after heavy rainy day or cloudy day are muted. This is muted color. This whole line represents muted color. Okay. So that is it for today. Let me know if it helped you, and if it didn't, let me know that as well. And yeah, please feel free to ask whenever a doubt strikes, or if you have any other queries. Yeah, so I'll see you in the next video lecture. Till then, take care.